Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about the central limit theorem. All right, so when working with a sampling distribution of means, as the sample size increases, the distribution becomes more and more normal. So we can assume normality if n, our sample size, is greater than or equal to 30. Okay, if that's the case, then the central limit theorem kicks in, and we know that the sampling distribution will be roughly normal. We can also assume normality if the population distribution is known to be normal, or if the graph of the data is unimodal and roughly symmetric. All right, so here are just kind of some rough pictures of different distributions, and you can see like skewed right, uniform, multimodal, skewed left. If I do a sampling distribution of the sample means, my distribution is going to basically become normal. If the sample size is large, no matter what the population distribution looks like, the sampling distribution of sample means will be approximately normal. If the sample is small, the sampling distribution will look like the population distribution, however, slightly more normal looking. Okay, and as the sample size gets bigger, it gets more and more normal looking. All right, given the parent distribution graph, what is the sampling distribution? What would the sampling distribution look like given the different sample sizes? So I have n is 5, n is 15, and n is 50. I know that as my sample size increases, my distribution is going to look more and more normal. So the first one, when n is 5, it's still going to be kind of bimodal and kind of skewed to the right. But it does look a little bit more smoothed out for the sampling distribution than as staggered with the histogram. And then when n is 15, when my sample size is 15, it's going to be a little bit more unimodal and more symmetric. However, it's going to be a little bit more spread out. And then when n is 50, all of those values, because again, you're taking a sample and you're getting a mean, and then you're getting another mean, and you're getting another mean, and you're getting another mean. You're taking all of these statistics from a sample and you're graphing them. And so a lot of them, when your sample size is 50, are going to be more accurate. So remember when we worked with the fractions, as we got more specific fractions, we got closer to the truth. So more of them, it's going to be more of a peek at the true value, the true mean of the sampling distribution. So if n is really large, it'll be really normal looking. All right, go Seahawks.